Hello everyone, in this video I'll be explaining you the problem cut the array, and it was asked in Educational Codeforces Round 182 for Division 2. So you are given an integer array of n non-negative integers. You are given an array of non-negative integers a1, a2 up till an. Your task is to cut it into three non-empty parts: a prefix, a middle part, and a suffix. Formally, you need to choose two integers L and R such that L is greater than or equals to 1 and L is less than R. R is greater than L, less than N, and obtain three parts. Okay, so the prefix of the elements at index L, which is basically from A1 to L, the central part of the element at index L plus 1 to the element at the index R. Basically, yeah, central part, the middle part will start from AL plus 1 till AR, and the suffix part will start from AR plus 1 till AN. And it is 1 based indexing, that's why we are starting with A1 and we are ending with AN. So let S1, S2, S3 be the reminders of the sum of three parts modulo 3. In other words, what they are saying is that S1 is basically the sum of A1 till AL, from A1 till AL modulo 3. In the same way, S2 is basically the sum of these elements modulo 3, and the last sum is basically suffix sum is basically sum of these elements modulo 3. So your task is to find such boundaries L and R that either all numbers, the number S1, S2, S3 are different, all are different, or all numbers S1, S2, S3 are the same. Okay. So input the given, first they have given the test cases, and for each test case we have integer n, and here see n is very small, like from the length of the array is from 3 to 40. So the constraint is very small, so we can brute force the solution. So I'll be telling you brute force approach only. The second line contains n integers, a1 up till an, and the value is from 0 to 40. So that is fine. So let's take one example and understand. In the first case we have 1 2 3 4 5 6. So n is basically length of the array, and this n is ranging from, there will be at least 3 elements and at the max 40 elements. So n is very small. Even if you do n cube or n power 4 solution, this is going to work, because n power 4 will give you 16 into 16, which is 256, into 10 power 4. So it will be like 2.56 into 10 power 6. So it is lesser than 10 power 8. So it is going to run. Even I will be solving using n power 4 approach. So so the array elements are 1 2 3 4 5 6. In this case, what they are asking is basically you need to divide the array into three sub arrays. So let's say I considered L as this point and R as this point. So L is basically till here, not here, we don't have anything. This is L index. Let me write it here. So these are index, and this is basically R. So S1 is basically summation of elements from A1 till L. S2 is summation of AIs. Let me write this only, AI, and this I is running from 1 to L, and this whole thing you mod it with 3. See, in the similar way, S2 is basically I is from L plus 1 till R. Now you take whole thing modulo with 3, and S3 you take as summation of AI, and this I is from R plus 1 till N, whole thing you mod it with 3. So I think this you have understood. It's like you start from 1 until L. So in this case, since I've taken partition this way, so S1 here will be simply one element, and modulo 3 will give you 1 only. S2 is like 2, and then modulo 3 if you do, you're getting 2 only. And now your all this sum will be this is 9 18 18 modulo 3 is going to give you 0. So as you can see, S1 S2 S3 all the elements are different, So this is one of the valid, left and right. So we need to print left as 1 and right as 2. So we need to print this value, L is equal to this and R is equal to this. So in the first case, like we have got directly the solution. It may happen that you will have to choose the other way around. So let's say if you do partition here, so if you do partition here, your L remains same, sum, because 1 we have 1 modulo 3 is 3, but these 2 is 5, right? So 5 modulo 3 is again 2, but here the sum is 9 plus 6, which is 15. 15 modulo 3 is 0. So here also this is also a valid one. So you can also write like 1 comma 3. You can also print 1 comma 3. So in order to solve this, like we'll have to consider all the cases. Like it may happen that like you have taken in the prefix as 1 and in the suffix as 2 and rest all elements in the some middle as 2 and all elements in the suffix. This is one of the possible combination. So now you increase this range, the middle part. So you are taking 1 3. Now 4 5 6 will come in suffix part. This is prefix, this is middle part, and this is suffix. So now if you try to increase again, and this is one of the again possible partition. Now you take again, this is also one of the possible partitions. So in this case what we have done is we have kept your prefix part as constant and we are moving only the right hand this line. So this is one of the possible combinations. Now if you try to do the other way around, let's say you take in prefix part 1 comma 2, then the least the element you can take in middle is 3, then 4 5 6 you will take. Now you keep this as constant, and this is also one of the possible combination, and this is other. So what I'm trying to say is that you will have to keep one part as constant, and then you try to move the other part and see what is the possible sum you will getting. So in this case you need 3 variables to keep track of till which the index is happening. Let's say I will keep track of the like the first part, prefix part, till which index we have considered the sum, that is going to track. And then let's say one more index will take j. This will keep track of from I plus 1 till j index we have taken the summation, and this part will take from j plus 1 till k last element n, right? Like since we have to take all the sums, so that's why all the sums, I mean all the values has to be in one of the partitions, and it's like continuous, it should be a subarray kind of thing. So what I'll be doing is I'll be taking one integer I. This will start from 0 and I will go till L as one of the partition. Now your this is j, your j will start from L plus 1 and j will go till R, and I'll take one more variable k to keep track of this thing. So k will run from j plus 1 till n right? So if you try to write the pseudo code for this, like basically we'll take one for loop, and this is I, which will start from 0 to L as one of the partition, and one more for loop you will take j. This will start from I plus 1, because when you're starting with 0, sorry, it will not start from I plus 1, it will start from L plus 1. Like what does this mean is that, let's say you have taken only this element, so it's like from 0 till L. So the j, the middle part has start from L plus 1 to R. Let's say this is R. Now you will take one more for loop k, which will run from R plus 1, because this is the last part we are considering, and this will consider till n. Now you need to find the sum of elements in each part. So for that, one more for loop I'll be taking. I'll be calling index as idx, which will run from 0 to n. And now I'll be taking, before this I'll be taking s1 to be sum of the prefix part, which is 0 initially, s2 as sum of the middle part, which is 0 initially, and s3 as sum of the last part, which is also 0 initially. So now in this third for loop, what I'll be doing is I'll be checking if this index is lesser than equals to L. So I'll be adding the sum in s1. s1 plus equals to, your array is like a, so it will be a of index, right? So this for loop will make sure that we are storing the sum into s1, s2, s3. So s1 we have taken care of. Else if what we'll do is we'll check if this index is lesser than equals to r, which in first case whenever it starts from 0 and whenever the index is less than equals to L, so always the sum will be stored in this. Whenever L is exceeding, index is exceeding L, so this condition will fail and will come into second condition. Now since we know after L your sum has to go in s2, so in s2 we'll be storing a of index, right? Let me write here now. Else, which means if your index is lesser than equals to r is false, which means your index is greater than r. If it is greater than r, then it will go in s3 part. So whatever elements you have, you will have to store in s3. So we will store all the elements in this s3, and in this for loop only, since we have got after this for loop, since we have got s1, s2, s3, we will do modular with 3 in all the elements, and we will try to check if that s1 equals to s2, which means if all the s1, s2, s3 are equal, or if all the elements are different. Then if that is the case, then whatever L and R we have, that we need to print. So in this case, if you see what will be the L, L is basically it will be right, like L is basically whatever j index you have. So j is started from L plus 1, so your L will be j minus 1, and your R will be, since k started from R plus 1, so k minus 1 if you take, that is L and R. I think you guys got to know. And this for loop actually will be running from 0 till n, not like we are checking all the cases, like once we are taking only one element, then we are taking 2 elements, and then we are taking 3 elements. So the index whatever at which we are, so that is basically you can take this Li also or L also. So these for loops will be running till n only. All the for loops will be running till n. This will be actually running till n minus 2, not n, and this will be running till n minus 1. This is actually n minus 3 because it is starting from 0, and this is n minus 2, and this is n minus 1. So I think you guys are getting right. So here if you see your j will always start from I plus 1. L is basically as I said j minus 1, right? So it will be starting from I plus 1, because till here let's say you have taken this sum s1, so your s2 will start from at this position I plus 1, and your k will start from j plus 1. So yeah, this is the if you try to do it brute force way, so this is going to accept. So let me just erase this, and in the first line we have integer t denoting number of test cases, so I have taken care here, and for every test case we have integer n, and for every n we have n integers, which is in array A. So we will take all the input values, right, and we need to run a loop I, which is starting from 0 till n, I plus plus. Your j will start from I plus 1, j less than n, j plus plus, and your k will start from j plus 1, k plus plus. One more loop I'll be taking int index. As I said, I'll be calculating the sum. So right before going into this, we'll have to take sum s1 as 0, s2 as 0, and s3 as 0. We need to check if the index is lesser than or equals to I, which is L in our case. We can take I or we can take L as well. That is fine. So we'll be adding in s1, else if since I mean the index is greater than I, which means it is lying in the range J, lying in the S2. So whenever that is lesser than or equals to S2, so we'll put in S2, else we'll put in S3. So when we come out of the loop, we need to find S1 as modulo 3, S2 as again modulo 3, and S3 as modulo 3, because that is asked in the question. Now we need to check if this S1 is equals to S2 and S2 equals to S3, which means all the elements are equal. If that is the case, so in that case we need to print the index of the left and right. Else one more case they have said, if S1 not equals to S2 and S2 not equals to S3 and S3 not equals to, which means all the elements are different. If all the elements are different, so in that case also your partition is valid. So you will have to print I separated with J, and you need to return. And if the partition is not valid, so they have asked in the question, otherwise output two integers equal to 0. If the partition is not valid, so you need to print 0, 0, 0 space separated with 0. So let's try to run it. Here it is going to fail because there are multiple ways we need to do it. And one more thing, okay, so I'm printing based on index 0, so we should be printing based on index 1. So I'll be taking I plus 1, right? Because I'm considering since vector starts from 0 index, so I'm considering from 0, but you need to take 1 best, so I'm doing plus 1. So here now it is going to fail, but if I submit in, because there are multiple answers for this, so if I submit in ID, so it is going to accept. Cut the array. So yeah, it got accepted. In this way, we could have easily solved the problem. So it was a brute force problem. Basically, the time complexity of this is n power 4, and space complexity is O of 1 constant. We are not using any extra space to solve the problem. We are indeed storing the elements in a vector, but this is a part of input, right? So we should not be considering when you are solving the problems. So yeah, I think you guys got to know how to solve this. Basically what you have to do is you need to stress the partition from one size till the maximum possible size in all the s1, s2, s3. So you have to take all the possible sizes of the s1, s2, s3 and take those sums, and then take modulo 3, and then check if the modulus, I mean s1, s2, s3 are equal, or if all the three elements are different. So in that case you have a valid partition. So for that you need to print wherever it partition happened, and else if you are not able to find the solution, so in that case you need to output 0 and 0 as asked in the question. So yeah, thank you guys for watching the video.